Hey there, linear algebra. Dr. Brad here. I need to make a video for Friday's class for a few different reasons, but this is the way we're going to do class for Friday, February the 22nd, which is tomorrow, the last Friday prior to spring break. So you can see here on the screen, I think I got us set up where we can do this pretty well. Hi, this is me down here in the corner. I'll be running the PowerPoint up here, and then I've got this camera to show as we work through an example on paper. So I think this is pretty close to what we do in class with the PowerPoint and when I work on the board. But here we go. We are in section 3, and we are talking about adjoint, inverse, and Cramer's rule. And let's get to it. There are two of the definitions that we're going to start with. There is a new, another formula for the inverse of a matrix, and you can see here that inverse is 1 divided by the determinant, and then this is new for today. This is what's called the adjoint, ADJOINT, and you saw it in the title just on the previous slide. So we'll be using this equation today to calculate inverses of matrices. And then Cramer's rule says this: if you've got matrix A that's invertible and AX equals B, then you can solve for each one of the values in the vector x, like x1, x2, x3, by replacing, and this is not obvious in the definition here on the screen, but you can calculate the value of x1, x2, x3 by replacing, for x1, replacing column 1 with B, for x2 replacing column 2 with B, and x3 replacing column 3 with B, and so on. And then take the calculated determinant of that and dividing by the determinant of A. Those are the two things we're going to be doing today. If I stopped right here, I'm pretty sure you'd be so confused. So we've got to look at an example. So here we go. Definition of what an adjoint of a matrix. An adjoint is the transpose of the cofactors. So there's two things going on there. First of all, you calculate the cofactors, and then you calculate the transpose. And then after you calculate the adjoint, you can calculate the inverse by taking 1 over the determinant times the adjoint. Okay? Now, if we're talking about a 2 by 2 matrix, it's pretty simple. The adjoint is simply this, because it's the determinant of the, it's the cofactors, sorry, not the determinant, it's just the cofactors. And then if we apply the equation that we saw up here, 1 over the determinant times the adjoint, we get this. You have seen this before. This is the equation that we saw for the inverse of a 2 by 2 matrix. So here you have the determinant, here you have the adjoint. It's super simple with a 2 by 2, so we need to move on and see what it looks like for a 3 by 3. So we're going to use this guy right here as our example. And so we've got the matrix -1, 3, 2, 0, -2, 1, 1, 0, -2. So the adjoint is this. How in the world do they figure that out? Well, here we go. I got to show you some steps to fill in the gaps. So if this is our matrix A, and you've got -1, 3, 2, 0, -2, 1, 1, 0, -2, then let's take this a step at a time, because remember, the adjoint is the transpose of the cofactors. And so first of all, let's figure out the cofactors. And that's going to look like this. So for -1, up here in this corner, you're going to have 4 minus 0. Okay, working our way across to the 3. If we took out the first row and the second column, we'd have 0 minus 1, which is -1. But remember, this goes positive, negative, so the negative of that. So 0 minus 1 is -1, plus minus of -1 is just +1. And then in this spot here, the cofactor is 0 minus a -2, which is +2. So plus minus plus, so we keep that the same. Okay, and then the cofactor expansion for this guy, he's in the first column, second row, so we pull that out. It's just going to be -6 minus 0 plus minus plus minus, so that's +6. And then for here, pull out the middle column and the middle row, it's going to be +2 minus 2, which is 0. And then in this position here, pull out the second row and third column. We're just going to have 0 minus 3, which is -3, but plus minus plus minus. So the minus of -3 is +3. Continuing on with this, and you can check it, but you're going to end up with, in this case, you're going to end up with 7, 1, and 2. Want me just to check the 7 for you? It's going to be 3 minus a -4, which is 3 plus 4, which is 7, plus minus plus. So here's the cofactors, and so the adjoint of A is the transpose of the cofactors. So the first row becomes the first column, second row becomes the second column, third row becomes the third column, and there you go. That's how they ended up with, who's they? They is me, since I prepared this. That's how we end up with this adjoint for the matrix A. So here's the adjoint. You can plug the matrix A into your calculator. Go ahead and do that. -1, 3, 2, 0, -2, 1, 1, 0, -2. Go into second matrix, math, and calculate the determinant. Just for practice, make sure you get 3 as the determinant. So for the example that we have up here on the screen, the determinant is equal to 3. So we have the adjoint, we have the determinant, so the inverse of A is 1 divided by the adjoint, the determinant, sorry, 1 divided by the determinant, so that's where we get the 1/3. The determinant is 3, 1 over 3, times the adjoint, 4, 6, 7, 1, 0, 1, 2, 3, 2. And so the inverse for matrix A, here's A, here's the adjoint, here's the determinant. Put all that together, the adjoint and the determinant gives you this matrix right here as your inverse. Okay? Now we can check that if we so choose to. We can check that by multiplying A times its inverse, and when you do that you get 1, 1, 1. Alright, so we know that yes indeed this is the inverse of A. Okay? Now that's what you have in the PowerPoint. I want to walk you through another example. And so if we take these 3 equations, -3 x minus 5y minus 7z equals 12, and you can see it there. There's 3 equations, 3 unknowns. We can put together the coefficient matrix. Coefficient matrix you have there: -3, -5, 7, 2, 4, 3, 0, 1, -1. Okay, and we can calculate the adjoint for this. So first of all, let's just look at the cofactor expansion, and then we'll take the transpose of this. After we take the cofactor expansion, we'll take the transpose, and that'll give us the adjoint. Okay? So remember, we've got this pattern of plus, minus, plus, plus, minus, plus, minus, plus, minus, plus. So that'll come into play here. Negative 4 minus 3 is negative 7. Negative 4 minus 3 is negative 7, so that's just going to be, in this case, negative 7. Okay? And then working our way across to this position, we've got negative 2 minus 0, but the negative of that is positive 2. Okay? And then for the third, it's going to be 2 minus 0, which is 2 again. Okay? For down here, taking out the first column and second row, we have positive 5 minus a negative 7, which is going to be 12. Okay? And that's positive, so sorry, I lost my train of thought here. Positive 5 minus a negative 7, so that's positive 12, and make that a minus in this case since it's in this position. And then right here in the middle you have 3 minus 0, so that's just 3. And then over here, taking out the second row in the third column, you have negative 3 minus 0, which is, and then the negative of that is going to be positive 3. Okay? And then finally, taking out the first column and third row, you have negative 15 minus a negative 28. Okay? Negative 15 minus a negative 28 is 13, and you have negative 9 minus negative 14, which is 5, but this is negative, so negative 5. And then finally down here in this corner, for this position here, we have negative 12 minus negative 10, or plus 10, which is negative 2, and we keep that positive, so negative 2. That's the cofactors, so we slide that right in here. The adjoint of A is going to be, if we fit that in here, we've got negative 7, negative 12, 13, 2, 3, negative 5, and 2, 3, negative 2. That, my friends, is the adjoint of A. Okay, so if you plug in this matrix right here, if you plug this matrix into your calculator and you calculate the determinant, feel free to go ahead and do that. If you want to push pause, punch this in, calculate the determinant, you'll see what this ends up with. Give you a minute to do that. Welcome back. For those of you who did pause, the determinant turns out to be negative 3. And so what we get for the inverse of A, that's 1 over the determinant, which is negative 3, times this adjoint of that. And so all you're going to do is run through and divide by -3. So the inverse is equal to 7/3 dividing by -3, 4, -13/3, -2/3, -1, 5/3. Taking each one of these and dividing by -3, and you get again -2/3, -1, and 2/3. And that is the inverse of matrix A. Okay, I am going to stop this video just so that each one of these is not so terribly long, and when I come back in the second part, we'll continue on with Cramer's rule and look at an example with that. Okay, look for part 2.